All right, let's dig into this. What is artificial intelligence, really? I mean, it's this buzzword that's just everywhere, right?
Right.
From your phone, helping you find, a restaurant to these complex systems and self-driving cars. But honestly, all the jargon, it can feel overwhelming.
It really can.
Yeah.
Makes it hard to grasp what's actually going on beneath the surface.
Exactly. So today, we're doing a deep dive, not just defining AI, but really trying to break down how it works, what makes it tick, and maybe most importantly, how you can actually use it.
Use it right now, yeah.
Yeah.
To sort of future-proof your skills, your career, whatever you're doing.
Yeah.
And what's great, looking at our source material, the AI Ascent, is how it really demystifies AI. It helps you see it's not some impenetrable black box.
Right.
It's more like a set of tools built on clear principles. And understanding those principles, that's the key for you to actually apply this knowledge.
It gives you that shortcut, maybe, to get those aha moments without feeling like you're drowning in info.
Precisely. Enhancing your own capabilities, that's the goal.
Okay, so for anyone wanting to really get this, we need to set the stage. The basic concepts. AI isn't just one thing. We know that.
Not at all.
When we talk about automating tasks that usually need human intelligence, what are the main ways AI goes about it? Like the big categories?
Good question. The source highlights two main types, and they're pretty fundamental. First, you've got rule-based AI.
Okay.
Think of this like traditional programming or maybe expert systems. It runs on really explicit rules that humans define beforehand.
Like a strict flowchart. If this and that, then do this other thing.
Exactly like that. Using logic like AND or, not T, it's based on an expert's knowledge, hard-coded in. Very precise for problems you can clearly define.
Got it. Clear instructions, clear outcomes, but what if the problem's too complex or the rules keep changing? That sounds like a job for something else.
That's perfectly put. That's where ML-based AI, machine learning, really shines.
Okay.
So instead of a human writing every single rule, you have an algorithm that learns patterns directly from data.
Ah, so it generates the rules itself, in a way.
You can think of it like that, yeah. A rule generator. The output isn't those hard-coded instructions, but a model. And that model has sort of internalized the rules it found.
And then it applies those learned rules to new stuff, new data.
Exactly.
Yeah.
And within ML, there are a couple of main approaches you'll hear about most often. There's supervised learning.
That's like teaching it with examples, like showing it pictures of cats to teach it cat.
Perfect analogy. It learns from labeled examples, powers a lot of prediction tools, fraud detection, things like that.
Okay.
Then there's reinforcement learning. You see that a lot in robotics or AI playing games. It learns by trial and error, gets rewards or penalties.
Like training a dog with treats?
Kind of, yeah. It figures out the best actions over time. There's also unsupervised learning, finding patterns without labels, but supervised and reinforcement are probably the key ones for understanding practical applications right now.
Okay, that shift from telling the machine to showing it how to learn, that's huge. And when we talk about the really cutting edge stuff today, like the conversational AIs everywhere,
Yeah, like ChatGPT and others.
we're usually talking about something even more complex, right? Artificial neural networks. How do they fit in?
Right, ANNs. They're models inspired, sort of loosely, by the brain's structure, layers of interconnected neurons.
Layers.
Yeah, data comes in through an input layer, goes through one or more hidden layers. That's where the calculations happen. And then you get a result from the output layer.
Okay.
Now, here's the kicker. When you have multiple hidden layers, maybe lots of them, that's what we call deep learning.
Ah, deep learning. That's the term you hear constantly.
Exactly. And that depth, those extra layers, lets these models find incredibly complex patterns, things that simpler models would just miss. It's behind so many of the recent breakthroughs.
And it's not just theory, right? Deep learning is driving actual applications we use. The source mentioned a few key types.
Oh, absolutely. Things impacting you daily, probably without you even realizing it. Take Transformers.
Transformers,
Yeah.
not the movie robots.
No, not those. It's a specific revolutionary architecture. It's the engine behind large language models, the LLMs.
The ones that talk like humans.
Right. Their magic is this attention mechanism. They can figure out which words in a sentence are important, even if they're far apart. That's how they get context and sound so coherent.
Wow. Okay. What else?
Then you have generative adversarial networks, or GANs. They're used in generative AI.
Creating things. Like images?
Exactly. Creating super realistic data images, audio, video, that can be almost impossible to tell from the real thing.
Okay, that's slightly scary, but powerful.
It is. And for things like self-driving cars or reading medical scans or robotics, Convolutional neural networks, CNNs, are vital. They're brilliant in processing visual data, seeing and identifying objects.
So these are the complex brains doing the work, but like any tool or even a person learning, how do we know if an AI is actually good? How do we evaluate them properly?
Great point. That's model evaluation. You have to test the model rigorously using new data it hasn't seen during training.
Like giving it a final exam it hasn't seen the answers to.
Exactly. And you use clear metrics like accuracy. Think of it like grading that exam. But it's not always simple. There are pitfalls.
Like,
Well, overfitting is a big one. The model basically memorizes the training data perfectly.
so it aces the practice tests.
Right. But
Yeah.
then it sees new, slightly different data in the real world, and it just falls apart.
Yeah.
It memorized the answers, but didn't understand the subject.
Okay, I get that. Knows the answer, but not the why.
Precisely. The opposite is underfitting.
Yeah.
The model just learns too little. It does badly on all data, training or new, like skimming the book and missing the point entirely.
Right. And there's another one, especially for those language models, hallucination.
Yes. Critical concept for LLMs. Hallucination is when the model just makes stuff up. But it sounds completely convincing.
It presents false information as fact.
Exactly. It guesses, but states it like a fact. Like, I asked one about a historical event last week, and it confidently gave me a date that was off by 50 years. You really have to double check.
Wow. Okay, so we have these models, but AI systems can be more complex than just one model, right? The source mentions AI agents and orchestrators.
Yeah, that's moving towards more complex systems.
Mm.
Think of AI agents as autonomous specialists. They're designed to do specific tasks. They might use rule-based AI or ML or a mix.
Like specialized workers.
Exactly. Then an orchestrator is like the manager or controller. It's a framework that manages multiple AI agents, coordinates their work, makes sure they interact properly.
Ah, like a conductor for an AI orchestra.
That's a great way to put it. You see this in complex systems. Self-driving cars are a prime example. Agents for vision, navigation, decision-making, all managed by an orchestrator. Or sophisticated software that automates whole business processes using multiple agents.
Okay. And briefly, the source touches on levels of AI intelligence. Where do things stand?
Right. The distinctions are usually ANI, artificial narrow intelligence.
Yeah.
That's basically all AI today. Really good at one specific thing like chess or translation, but that's it.
Okay, so not general intelligence yet.
No, that's AGI, artificial general intelligence. Human-like reasoning across many tasks. It's still very much research. And beyond that is ASI, artificial superintelligence, which is capabilities far exceeding human intellect. Purely theoretical right now.
So understanding that most AI is narrow is important context.
Crucial.
Mhm.
It highlights its strengths, but also its current, very real limitations. Oh, and the Turing test. That's just a classic idea for measuring if an AI can mimic human conversation well enough to fool someone.
Got it. And this really leads us back to a core idea from the AI ascent, doesn't it? This human-AI partnership.
Absolutely. It's not about replacement. It's about partnership.
Because AI is great at some things, humans at others.
Precisely. AI excels at data tasks, finding patterns in massive data sets, super fast calculations, repetitive actions. Humans bring the creativity, the critical thinking, the strategy, the nuance.
So together, they're more powerful.
Much more. It's a symbiotic relationship.
Okay, that makes sense. Which leads us neatly into the nuts and bolts, how AI actually works day to day. If AI is like a recipe, what are the core ingredients?
The source breaks it down nicely into 3 core components. You need all 3. First, data. That's your ingredients.
Okay.
Just like cooking,
Quality matters.
massively.
Yeah.
Good, clean, relevant data is everything.
Right.
Second, algorithms. These are your recipes. The steps the AI takes to process the data classification, prediction, clustering, whatever the task is.
Okay, data and recipes. What's the third?
The applications. That's the final dish. Your virtual assistant, your problem solver, your content generator, the thing that actually does something useful.
And this all connects directly to that famous phrase, garbage in, garbage out. Gee, I go.
Fundamental. Absolutely fundamental. And it's where you, the user, have real influence.
Because if you feed it bad stuff,
You get bad stuff back. Incomplete info, vague questions lead to vague, unhelpful answers. The source really pushes for clear communication. Your questions need to be specific. Vague questions get vague answers. You need to provide context, give the AI the background it needs, And using action-oriented framing helps it understand exactly what you want it to do.
Okay, so being clear and direct, and this is where prompt engineering fits in, right? Learning how to talk to the AI effectively.
Exactly. Especially with LLMs. It's about mastering that interaction. The source gives some really practical techniques.
Like what?
Well, you can be direct. List 3 benefits of X. Simple. You can be instructional. Explain step by step how to do Y. You can provide context. Act as a specific role, like a financial analyst, and explain Z.
Setting the stage for it.
Right. And another powerful one is few-shot prompting. You give the AI a couple of examples of the kind of output you want. It learns from your examples before generating its response.
That makes sense. You show it what good looks like. The source had some great lab examples too, didn't it? Like the prompt refinement one.
Yeah, that one's so relatable because we've all done it. It shows the difference between asking something vague like, help me with my report.
Which gets you nothing useful.
Right. Versus being specific and contextual, like, as a project manager, draft 3 key risks for the upcoming software launch focusing on resource allocation and timeline. Suddenly, you get something actionable.
It's like asking a chef for food versus asking for a medium rare burger with fries. Specificity gets results.
Perfect analogy. Specificity is key.
And they also mentioned using AI for things like data cleaning, even if you're not a coder.
Yeah, that's a really practical use case.
Mm.
The source shows how you can use an LLM, just by asking in plain English, to analyze messy data, like customer feedback spreadsheets.
So you could ask it to find common complaints in these reviews, or are there any weird outliers in the sales data?
Exactly. It can help you extract insights, spot trends, even suggest how to visualize the data,
Yeah.
all without you needing to write complex code.
Okay, so the big takeaway here, the absolute foundation is quality input equals quality output.
That's the bedrock. Clean data, specific prompts. That's how you get reliable, useful AI results. Everything else builds on that.
Which brings us to the next big idea. There's no free lunch in AI. It's not just plug and play magic.
Not at all. That's a core principle. There isn't one single AI solution that works perfectly for every problem right out of the box.
You have to tweak it, iterate.
Constantly. Customization through iteration is essential. You can't just grab a model or write one prompt and expect it to solve your unique challenges flawlessly. It needs refinement, testing, adapting.
And for really complex stuff, that's where those AI agents and orchestrators come back in, doing more than just a single prompt can handle.
Definitely. Think about that orchestrator and AI agents lab example from the source. It paints a clear picture.
How did that work again?
You had Agent A, the researcher, gathering data, say, on global EV sales trends.
Yeah.
Then Agent B, the analyst, crunches that data, finds the key insights, the barriers.
Okay.
And finally, Agent C, the writer, takes those analyzed findings and synthesizes them into a structured report.
And the orchestrator manages the whole flow.
Exactly. It directs the agents, maybe validates sources, cross-checks stats. It shows how you can chain AI capabilities together for really complex, multi-step tasks that go way beyond a single interaction.
So it's definitely not a one-shot deal. It's more like a continuous improvement loop.
Precisely. You iterate. You try different data variations, different model settings. You test different approaches. You constantly refine your prompts. It's an ongoing process of learning and adapting to get better results.
Which leads us right to the crucial part, the why you care moment for everyone listening. Because AI isn't just for tech experts anymore.
Not at all. It's becoming a tool for everyone.
To boost your own skills, stay relevant. How does the AI ascent suggest we actually do that? How do we future-proof ourselves?
It's really about using AI to deepen your expertise in whatever your field is. The source suggests using AI to build out mind maps of your profession.
Mind maps? How?
Well, for your foundation, you can prompt an AI to outline the core theories, the key terms, the absolute essential principles of your domain.
Okay, solidifying the basics.
Right. Then for skills, ask it to map out the standard tools people use, the common methods, the best practices in your industry.
What about staying current? That feels critical.
Absolutely. And that's awareness. Use AI to quickly track recent developments, spot emerging trends, see influences from other fields, even find relevant certifications or ethical guidelines.
So AI becomes like a personal research assistant building this knowledge map for you.
Exactly. It synthesizes vast amounts of info incredibly fast, helping you stay ahead.
And beyond just understanding your field better, AI can directly help with, well, technical skills, even if you don't think of your job as technical.
Definitely. Take data literacy. Even if you don't code, AI can help you figure out what data sources are relevant, what questions you should ask of that data, what metrics actually matter for your role.
Making data less intimidating.
Yes. And automation. You can literally brainstorm with the AI. Ask it, how could AI streamline tasks in my job as your role? Get practical prompts for efficiency, maybe find less obvious ways to use AI tools you already have access to.
Like asking, as a teacher, suggest prompts to help automate grading feedback for common essay mistakes.
Perfect example. It makes automation accessible.
Importantly, this doesn't replace those core human skills like critical thinking or problem solving. It boosts them.
That's the key insight. It's an amplifier. For critical thinking, use AI prompts to challenge your own assumptions. Ask it to argue the other side. Find potential biases in your reasoning. Fact-check claims.
Like a thinking partner.
Exactly. For problem solving, AI can help break down big, complex problems. Brainstorm way more solutions than you might alone. Explore what-if scenarios. What if we tried this alternative approach?
And adaptability, helping you learn new things quickly.
Absolutely. Need to get up to speed on a new technology impacting your industry. Ask AI to summarize it, explain its implications, point you to key resources. It speeds up that learning curve dramatically.
Okay, so it helps with foundational skills. What about those really human-centric skills? Communication, collaboration, creativity.
That's where humans truly shine, and AI becomes a powerful assistant. For communication, use AI prompts to refine your writing for clarity. Tailor your message for different audiences. Simplify complex ideas.
Like asking it, rephrase this technical paragraph for a non-expert audience.
Exactly. For collaboration, AI can help teams share knowledge more easily, brainstorm together, synthesize feedback from multiple people, ensure diverse perspectives are considered.
And creativity, that feels like the ultimate human domain.
It largely is. But AI can still help. Think of it as an inspiration machine. Give it a theme, ask for related concepts, use it as a rough draft generator, get it to visualize ideas.
So it provides starting points, options, but the human brings the spark.
Precisely. You provide the unique insight, the original thought, the artistic direction. AI assists. It doesn't originate true creativity in the human sense. It's a tool to augment your creativity.
This is great. So for listeners thinking, okay, where do I even start? The source gives some really concrete, practical prompt ideas, right? Things you can try literally today.
Absolutely. These are tangible starting points. For efficiency time management, try prompting your AI. I need to get specific task done. Help me break it down into small, manageable steps and suggest a logical order.
Simple but effective. What about problem solving?
Try. My client customer is facing specific problem. What are the most likely causes, and what follow-up questions should I ask them to get to the root of it?
Okay, useful. Communication.
I need to explain complex topic, maybe blockchain basics to my audience, e.g. marketing team. How can I simplify this clearly?
Research.
Where can I find reliable, current info on your industry topic, e.g. sustainable packaging innovations?
And even innovation.
Yeah. Your profession, e.g. graphic designer. What common frustrations do my clients have? Brainstorm potential new services or AI tools I could use to solve those.
Those are fantastic, practical examples. Anyone can start experimenting with those.
That's the idea. Start experimenting.
Okay, so wrapping this up, what does this all mean for you listening right now? We've covered the core AI concepts, how to talk to it effectively with good prompting, and really importantly, that it's not static. It takes iteration, partnership.
And that final principle from the AI Ascent just sums it up perfectly.
Yeah.
Successful AI collaboration demands continuous experimentation. It's not something you learn once. It's an ongoing skill you develop.
Yeah. AI is this incredibly powerful partner, right? It can
Yeah.
handle data analysis, text generation at speeds we just can't match. But, and this is the crucial but,
It relies entirely on you.
on your creativity, your critical thinking, your strategic direction. The future isn't AI just doing tasks for us.
No, it's about humans directing AI, amplifying our own unique abilities, bringing new ideas to life, solving problems in new ways.
So the real question we want to leave you with is this. What unique human creativity, what strategic insight will you bring to the table when you collaborate with these powerful tools? Don't wait. Pick your favorite tool, try some of those prompts, and just start experimenting today.